At Golden Barrel Technologies, we believe learning should be practical. This video gives you a glimpse of our free VLSI internship where students present what they have learned and how we guide them. Instead of just theory, we focus on understanding, implementation, and confidence. Let's take a look at how our students are learning step by step.
Good evening to one all present here. My name is Nirmal Kumar. I am pursuing ECE final year in Sedu Institute of Technology, Tamil Nadu. So first of all, we discuss about modern design verification methodologies in VLSI. First, we want to learn the concept of the design verification. So imagine you just spent 1,000 crores to build a brand new chip, but when it finally arrives from the factory, it doesn't even works. That's a nightmare, right? That's why design verification exists. In companies like Intel or Wipro, we live by the 70% rule, which means 70% of engineers and the budgets are spent just making sure the design actually works before we build it. It's basically a ultimate insurance policy for hardware. So this is the concept of design verification. Next, these are the methodologies. What are we used in the languages and methodologies? How do we talk about these chips to test them? We have a whole toolbox for language. System Verilog and UM are the industry heavyweights, but we can also Python use and C++ to build a reference model to act like a performance vision of the chip. Verification flow. First of all, we don't just start clicking buttons. We follow the plan. First, we do requirement extraction where we turn on a boring technical documentation into a list of things to test. Then we built a verification plan, which our master roadmap. After that, we run regression thousands of automated testers that hunts for the bugs while we sleep. While we finish, when the math proves we are testing every single corner of the design, we can call the coverage closure. This is the verification flow. So this is pre-silicon verification. This is post-silicon verification. This is the pillar of digital verification. This is a big one. Pre-silicon is like testing a car with a high-tech simulator. It slows. We can see the every single wire or gate inside it. So we can, if it has any bug or anything, means we can fix it cheap, around 1,000 or something. But not like post silicon. Post silicon is a testing that actual physical chip in a lab. It runs at a real world speed, but if you find a bug, there is a disaster because we have to remanufacture the whole thing that costs so many crores like that. So these are the silicon verification, the post silicon verification. So advanced verification tools. So we have three mains to catch up the bugs. First, static verification. These scans the code for structural mistakes without even running it. Second, the formal verification. This uses heavy math solvers like Jasper Hole to prove the bug is physically impossible to reach. And the third one, the final one, is dynamic simulation. This is a classic way to run the code in the simulator like VCS to see how it behaves in the real scenarios. These are the three verification tool sets. Next, digital electronics and fundamental design. We're getting back to the basics. Even the most advanced AI chips are made of the basic logic gates like AND, OR, NOT, XOR, MUX. We verify that complex code correctly to build these building blocks. We also check status transition between most bugs when the chip is moving from one task to another. We have to make sure it never gets stuck in the illegal state. That previous digital electronics is a main thing for design verification. Next, gate level simulation. So this gate level simulation that contain high level code is a bit of perfect world version of the chip. Gate level simulation is a reality checker. This is how we catch the unknown state that can crash a chip during startup or tiny glitches that might mess from the upper data from the last second. So next, RTL versus gate level logics. We think RTL as a high level and fast. It also about the logics and the algorithms. And next, other hand, gate level. It is a physical map of the gates. It much slower because it has to calculate timing, power. It has a only way to be 100% sure the chip will actually work in the real world. So that's why it contains RTL logics and gate level logics. Next, metastability and clock domain processing. When we have a slow part of the chip like 100 megahertz CPU and fast part like 400 megahertz memory, things can get messy. If the timing isn't perfect, a signal can stuck in the weird in between state that crashes the whole system. So we verify the design users to trick like a multi-flop synchronization to make these handshakes safely. So that's why we use metastability. At the last part is hardware security verification. Why we are using this? Modern chips have to be in lockdown like a vault. We verify key gates that keep the chips from working unless we have a right digital key. This stops people from stealing the design. We also check the malicious logics and even make sure the hackers can't see the password watching that chip power spikes. It also makes sure the chip only runs the software actually testers. So that's why we use these two gates, XOR and XNOR gates, for this hardware security verification. Thank you for giving me this opportunity to present with everyone.
Yeah, good. Nirmal Kumar, appreciable. Your content somewhat high standard compared to student level, so that's appreciable. Yeah, so you highlighted that
Thank you.
yeah, static verification, formal verification,
Yeah.
dynamic verification. That's good. So students, listen. So in the verification, so many verifications are there. Front end functional verification. There is a static verification, dynamic, assertion based verification, coverage driven, constraint random, formal verification. So many things are there. Okay, maybe you may be confusing with the different terminologies. So we started Golden Barrel one channel. So this is not about channel. Maybe it will be benefit to you. So because systematically from the basics onwards, I'm uploading lectures on that. Okay. So if you're confusing with these terminologies, if you want to get good clarity from the basics, I suggest you to go through that Golden Barrel channel. Even I have another channel, my own channel, but that is not that much systematic. I upload very random lectures. But if you go to Golden Barrel from the starting basics onwards, and we are trying to upload all domains also, okay, so that you will get very good clarity. That's why I'm suggesting. Okay, that's not about channel views or anything. Okay, right? Yeah. Okay, good.
Okay. Hello. Any doubts? You have
Yeah, yeah.
anything?
Yeah, Nirmal want to interact with you in the presentation. If you have any doubts or discussions, you can do that.